This is Senior Algebra, Section 1.7, Properties of Real Numbers. We're looking at a couple things today, some of the commutative associative identity properties, inverses, and the distributive properties. So definitely distributive property you've seen, other ones you've probably seen and forgot a little bit about. So let's talk a little bit about the properties here. The commutative properties, let's think about English here a little bit. When I say commutative, commute, when you think commute, and you think driving someplace, the commute to work, that type of stuff. When you commute, you move. So we say, or we think about this as the commutative property is I can move terms around and it doesn't change. Okay, they change places. So if I look, I have A plus B equals B plus A. Okay, what did happen? They switched. What does that mean? Well, it simply means this. When I have two numbers, when I'm adding here, so if I add 3 plus 4, I can switch places. That's the same as 4 plus 3. I get 7 in both cases. Notice, in addition, we can do that. In multiplication, we can do that. 3 times 4, same as 4 times 3. In subtraction, though, we can't. So just for addition, multiplication. The next one is the associative property. When you associate, who do you associate with? Okay, who do you hang with? Who are you grouped with? That's kind of what we think about with that. In this, I have A plus B plus C. All it's saying is this. When I have three things, I can add them in any order here. I can add them in any order. So, again, the same example. We have 3 plus 4. We're going to add one more, plus 5 here. When I add 3 plus 4 plus 5, I have choices here. I could add the 3 and the 4 first. Okay. So if I grouped those together, I could with parentheses. 3 and 4 is 7. 7 and 5 is 12. Or I could group the 4 and the 5 together. They show by using parentheses here. I could do 3 plus 9, and 3 plus 9 is 12. So I can group them in any order here with addition here. Again, with multiplication, I can do that. With subtraction, now I have some issues, so I can't do it there. The identity property. Okay, what is your identity? Your identity doesn't change. Okay, what does not change what I originally have? So if I start with A plus what number will give me exactly what I started with, A. Okay, in multiplication, A times what number will give me just A, what I started with here. If I look, in addition, it's 0. In multiplication, it's 1. Okay, 5 times 1 just gives me 5 here. Okay, what I started with. The identity, the beginning doesn't change. The inverse properties. We talked about inverses with multiplying and dividing fractions a little bit with that. We also see it in addition when we're solving equations. A plus the opposite of A is 0. When we think about multiplication, 5 times 1/5, remember 1/5 is the reciprocal. 5 times 1/5 gives me 1, okay, because I get 5 over 5. And again, I could see it in addition there. 8 plus negative 8 is 0. The last one, the distributive property. When I think about the distributive property, it's really a grouping type of thing. If I look, I'm going to take the number on the outside, A, and multiply it to every term on the inside. Some people like to use arrows there to show it. That's fine. I would suggest it just to make sure you don't forget any. So if I have 6 times the quantity, 2x plus 5, I have 6 groups of 2x plus 5. So I could write 2x plus 5 plus 2x plus 5, 2x plus 5, blah, 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 6 times. But, okay, we're going to use multiplication here. So I'm going to take 6 times 2x, and I'm going to take 6 times 5. Now, you don't necessarily have to write out this step. I am just showing you here. But we do get 12x plus 30. So, on to the examples. Our first example, we're going to be doing some distributing, okay, and we're looking to combine some like terms together here. So, in the first one, in A, we're going to distribute the negative 3. Now, the toughest part in distributing is not to make careless mistakes with negatives. If I looked at it as a negative 3 times a positive 5x, negative 3 times a positive 5x, Negative 3 and 5 is negative 15, so I have negative 15x. The more interesting one is the second part here. If I look, I can think of it as plus negative 8, or I can think of it as just a negative 8. Either way, I'm going to take a negative 3 times a negative 8. Negative times a negative would be a positive, so I get a positive 24 here. In B, I have 7 times 14. Now, if you wanted to try to do that in your head real quickly, might give you some issues here. Well, one way is to rewrite it in terms of a distributive property. Things with 10 are very easy to multiply, so I always break it into 10. Well, 7 times 10 is 70. 7 times 4, 28, and 70 plus 28. You can do that in your head. That's 98. So that's a strategy where you can multiply bigger numbers that you may not know offhand. Break it into something that you know and split it up. So in C and D here, now we're looking to simplify. When we talk about simplifying, we want to simplify like terms. Like terms, what are those? Those are terms that have the same variable, have the same exponent here. So we start off pretty easy. We have the 5x and we have a negative 8x. Again, you could write plus negative, that's fine. We also have a 12 and a negative 5. So I'm going to put those together. Remember about the negative here. That's the important part here. Don't drop that. So I'm going to show you why it works. Obviously, you do not have to do this every time, and we usually don't. But okay, why can I put 5x and negative 8x together? Well, it has to do with the distributive property. If I look to take out an x, take out the common term, what do I have left inside? 5 minus 8. Am I allowed to do that? Yeah, I am. The other side, plus 12 and a negative 5 is just 7 here. But now I can do 5 minus 8, which is negative 3. So I have negative 3x plus 7. In D, one of the most common mistakes that I see is dropping the negative here, not distributing the negative as well. Okay. Now again, some people like to go plus negative to make sure that they remember to do that. That's fine, you can do that. So I have 5 plus, and then a negative 3 times a 2x is a negative 6x, and a negative 3 times a negative 8, which is a positive 24. Plus 6x, and now I'm grouping things together. I'm going to look and I see a negative 6x and a positive 6x. I can group those together. And I can see a 5 and a 24 here. So what happens when I put negative 6x and 6x together? I get 0x. Well, what is 0 times x? What's 0 times anything? Just 0. So my x's cancel out there. Okay. What do I have left? A positive 5 and a positive 24. That gives me, when I put them together, a positive 29. All right, the last two. Okay, again, with negatives here, we see a little bit of a theme with distributing. The key in this one, the negative there, remember what number is that? That's really a negative 1 there. Okay, I'm going to put that negative 1 down. Okay, some people, again, like to do plus negative. So it's negative 8 plus a negative 1 times a negative times 2x is a negative 2x. Negative 1 times a negative 3 is a positive 3. And then I still have the plus 9x here. I'm going to look, what can I add together? What are my like terms? The positive 9x, the negative 2x. That just gives me 7x. The 3 and the negative 8, I'm going to put those together as well. So I do get 7x here. Negative 8 and a positive 3, that's going to be a negative 5x. So I just have that. I could write it either way, minus 5 or plus negative 5 here. In F, the last one here, we're going to factor out the common term. So if I look at 8x and 20, and that's a negative 20, I look, what can I factor out? What's the same? What's a common denominator? What goes into 8 and 20? Well, 4 does. So I start with 4 on the outside. I say 4 times what gives me 8x. Some people like to go 8 divided by 4. Same idea, same thing, that's fine. But I do get 2x there. When I do negative 20 divided by 4, or 4 times what gives me negative 20, I do get negative 5x, or negative 5. I can check my answers by distributing. So really there's no reason to make a bad mistake here when I can check. Oh, 4 times 2x, is that 8x? Yes. 4 times negative 5, is that negative 20? Yes.